All right, welcome America, welcome India, and welcome Selena Gomez to the live recording in Studio 202. Today we are going to graph a tangent function. We've got a phase shift, a vertical shift, got all sorts of stuff. It doesn't get any more difficult than this. I think the only thing this doesn't have is a reflection over the x-axis. So we'll go ahead and start. So let's take a look at the amplitude. Amplitude is always going to be positive. In this case, amplitude is 1/2. Oh, I don't like writing in black. We'll start with blue. Okay. So, got a lot going on in this problem. The period for the parent function of a tangent is pi, right? And the period will be pi over b. In this case, b is 4, the number in front of x. So if I take the pi and divide it by 4, pi divided by b, that's our period for this function. That's going to be pi over 4. The unit, we take the period and we cut it up into 4 nice even pieces. To do that, we just divide it by 4. And if I take pi over 4 and I divide it by 4, we never divide by fraction by a number. We always multiply by the reciprocal. So we're dividing by 4, we're multiplying by 1/4. That unit is going to be pi over 16. Tell me if you've got a question about that so far. So as soon as I get my unit, I'm going to come over to my graph and I'm going to put that on my graph because I know I'm counting by pi over 16. So since the period's pi over 4, this is 1 pi over 16, 2 pi over 16, 3 pi over 16, 4 pi over 16. 4 pi over 16, when you simplify it, you get pi over 4. So that's going to be 1 full period. All right, let's go to the phase shift. So this is kind of like our phase shift is our horizontal shift. So that's our H, and the vertical shift is our K. So this is like our H, K. This is our shift right here. So let's figure that out. To get the phase shift, the horizontal shift, we are going to set the parentheses equal to 0 and solve. So we've got 4x plus 3 pi over 4x plus 3 pi over 2 equals 0. So 4x equals negative 3 pi over 2. Just brought the 3 pi over 2 to the other side. And now I'm going to divide by 4. When I divide by 4, I'm going to multiply this side by 1/4, multiply by the reciprocal. I'm getting 3 pi over 8. Negative, right? Negative. So my phase shift is negative 3 pi over 8. And when you do your phase shift, you want to make sure you write if it's negative or positive, because that's going to tell you if it's going left or right. So this is going to be going left 3 pi over 8. And we have to think, well, how many 16ths is that? Because we're counting in 16ths. We'll get there in a minute. Let's do the vertical shift. The vertical shift is just up 1. And the way we say we're going up 1, we need to make sure we put the plus in front of that 1 so everyone knows we're going up rather than down. Now that we've got that, we can go ahead and move that 0, 0 to our new location. So we're going to go left 3 pi over 8 and up 1. So when I'm counting 3 pi over 8 left, I'm counting in 16ths. How many 16ths is that? Negative 3 pi over 8 is how many 16ths? Twice as many, right? It's going to be negative 6 pi over 16. Is everybody okay with that? All right, so 1, 2, 3, 4, 5, 6. There's negative 6 pi over 16 and up 1. I'll put that in red. Beautiful. And I'm going to go ahead and circle that just so we know that's our starting point. From there, before I forget, let me just draw that midline in where the vertical shift went, just so I don't forget. I have a tendency to forget my vertical shift. This is a good way to remember it. There's my midline for my graph. From there, we need the next 2 points. There's no reflection over the x-axis, so the graph's gonna go this way, right? And we've got that amplitude of 1/2. So instead of over 1, up 1, red. We're gonna go over 1, up 1/2. And when you're graphing a half, you're just estimating. You're just doing your best. And then it's gonna be down 1, over 1/2. From there, I want to draw my other asymptotes because I know the next unit over is an asymptote, and I'll do that in green. Yep. And while I'm at it, I'm just going to draw all my asymptotes because I know after every period, and we've cut that period into 4 sections because we're counting by the unit is 1/4 of the period. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, we'll do the domain and range after we get the graph. Now, I'll just fill it in, and I'll use black. So the graph has to be approaching the asymptote on either side, and we're going this direction since it's a positive tangent. So all the graphs should look like that, and now we can just copy that here and here and here. So let's do that again. Looks good. Any questions on that so far? Okay, the domain for this one is kind of tough. It's very similar to the last one, except for there's one extra step. Is everybody ready? Okay. When you have an asymptote, we're looking for the first one, and it's to the right of the y-axis. We start there, and then we count period k, plus period, plus period, plus period. In this case, our first asymptote is actually on the y-axis. So if we start there by saying, it can't be equal to 0, and then we add plus our period times k, it's kind of redundant. So if we ever happen to start on the y-axis, we can just say the next one is going to be period after 1 period times k. So 1 period, 2 periods, 3 periods, we can go this way. -1 period. K can be 1, 2, 3, -1, -2. So instead of going through all of that, we're going to write x cannot be whatever the period is times k. Pi over 4 times k. That's it. Now, in theory, you can pick any asymptote you want. Let's say I picked this asymptote, okay, which is at pi over 4. And I said the domain can't be pi over 4 plus pi over 4k. That's not wrong. It's just redundant because the period is actually the location of where the first asymptote is. So that's the only time we ever do that. For the range, it's still -infinity, positive infinity. We're gonna need a lot more explanation of this domain. Maybe I'll make a separate video just on domain of the tangent function. All right, peace out.